Next question, second, fifth and ninth terms of non-constant AP are in GP. So, let us start with terms are in AP. Second term of AP A plus D, and fifth term of AP A plus 4D, and ninth term of AP A plus 8D are in GP. These three terms are in GP, implies A plus 4D whole square equal to A plus 8D into A plus D. Since the terms are in GP, using GP condition we got this A square 16D square 8AD is equal to A square 9AD plus 8D square. A square gets cancelled, implies 8D square equal to AD. Since D not equal 0, because non-constant AP, that is why D never be 0, so cancel one D on both sides, remaining we got A equal to 8D. This is the condition with terms are in GP. Now the question is, what is common ratio of GP? To find the common ratio is equal to here fifth term is A plus 4D whole divided by second term is A plus D. Already we got A equal to 8D, so 12D whole divided by 9D gets cancelled, 12 by 9, 4 by 3 is the correct answer. So, based on progression, very simple question, using GP condition we got A equal to 8D, and then common ratio is 4 by 3. Next question, P equal to limit x tends to 0 plus 1 plus tan inverse root x whole power 1 by 2x. This is given data, then log P equal to. If you observe the given limit, by giving x is equal to 0 plus, that means slightly more than 0, this answer is 1 plus 0 1 to the power 1 by 0. This is in the form of 1 power infinity. For 1 power infinity, always we use e power limit x tends to 0 plus f of x minus 1 into g of x tan square root x minus 1 into g of x 1 by 2x, because our formula is if limit x tends to a 1 plus f of x whole power g of x is of the form tends to 1 power infinity, then answer is in the form of e power limit x tends to a f of x minus 1 into g of x. This is our formula. Based on that formula, we are proceeding the given problem. By substituting directly given limit, this is in the form of 1 power infinity. Since this is in the form of 1 power infinity, formula is e power limit x tends to a f of x minus 1 into g of x. For this, if x tends to a f of x power g of x is 1 power infinity, so you can write 1 plus f of x, or simply you can write limit x tends to a f of x whole power g of x is equal to 1 power infinity. Using this formula, we are proceeding the problem. 1 gets cancelled, e power limit x tends to 0 plus tan square root x by 2x tan square root x tan root x by root x whole square into 1 by 2. Now x tends to 0 plus, so tan theta by theta tends to 1, 1 square 1, answer is e power 1 by 2. So P equal to e power 1 by 2, but the question is log P equal to log e power 1 by 2, hence answer is half. Next question, f of x is equal to mod log 2 minus sin x and g of x is equal to f of x, then g of x is. Since g of x is equal to f of x, first prepare the function g of x, and that too our question is related to whether g of x is differentiable at x is equal to 0 or not differentiable at x is equal to 0. This type of options are given. So surrounding to 0, you can observe that this log 2 minus sin x, when x approaches to 0, sin x is slightly approaches to 0, 0 plus or 0 minus, this is log 2. Obviously log 2 minus sin x is always positive. So, when x tends to 0 implies log 2 is greater than sin x, hence f of x is equal to log 2 minus sin x, this is our f of x, and g of x is equal to f of x. So, f of log 2 minus sin x, that is equal to f of x is log 2 minus sin x log 2 minus sin of log 2 minus sin x, this is our g of x. Once again, our question is about whether g of x is differentiable at x is equal to 0 or not differentiable. These options are given. Surrounding to 0, when x approaches to 0, log 2 is always greater than sin x, because sin x tends to 0, 0 plus or 0 minus. Obviously, log 2 minus sin x is always positive, hence log 2 is greater than sin x, therefore f of x is equal to log 2 minus sin x. But our question is f of x is equal, g of x is equal to f of x. So, f of x is equal to log 2 minus sin x log 2 minus sin of log 2 minus sin x, this is our g of x. But the question is whether g of x is differentiable at x is equal to 0 or not. If it is differentiable, what is its value? So, g dash x is equal to log 2 is constant, derivative 0 minus sin derivative cos of log 2 minus sin x into inner derivative log 2 derivative 0 minus sin x derivative minus cos x, and the question is asking about g dash of 0, then minus into minus plus cos x cos 0 1, and this is sin 0 cos of log 2 is the answer. Whether you calculate x tends to 0 plus or x tends to 0 minus, f of x is same, that is why we calculate g of x directly. We got g of x is equal to this function, and g dash of 0 equal to cos of log 2. Next question, wire of length 2 units is cut into 2 parts. With one part a square is formed of side length x units, with another part circle is formed with radius r units. If sum of areas of circles and square is so formed is minimum, then find the relation between x and r. For this question, square of the side is x units already given and circle of radius r units already given. So, perimeter of the square and perimeter of the circle is equal to 2 units. Perimeter of the square equal to 4x, and for circle perimeter is nothing but circumference is equal to 2 units, hence 2x plus pi r is equal to 1 unit, hence r equal to 1 minus 2x by pi. This is the relation between r and x. Now our question is find the sum of areas of two diagrams, and that too the sum of areas formed is minimum. So, for a circle area is pi r square, and for square area is equal to x square. We want least value of s. So, since r equal to 1 minus 2x by pi, substitute here r value, pi into r square is 1 minus 2x whole square by pi square plus x square, 1 pi gets cancelled. For this s we have to find minimum value of s. For maximum or minimum, ds by dx is equal to 0. So, use that concept, ds by dx is equal to 0 implies 1 by pi multiplied by derivative of this 2 into 1 minus 2x into minus 2 plus 2x is equal to 0. In both sides take 2 cancel, remaining is here 1 by pi is only for this term, remaining derivative is 2x. So, here minus 2 into 1 minus 2x whole divided by pi plus x is equal to 0, or x is equal to 2 by pi into 1 minus 2x implies pi x is equal to 2 minus 4x, hence x into pi plus 4 equal to 2, x is equal to 2 by pi plus 4, this is value of x. But our question is find the relation between x and r. After getting x is equal to 2 by pi plus 4, substitute in this result, we will get r value. So, r is equal to 1 by pi into 1 minus 2x means 1 minus 4 by pi plus 4 is equal to 1 by pi into pi plus 4 minus 4, pi by pi plus 4 pi gets cancelled, r equal to 1 by pi plus 4 and x is equal to 2 by pi plus 4. Simply relation between x and r is x is equal to 2r is the correct answer. Next question, given that f of x is equal to tan inverse root over 1 plus sin x by 1 minus sin x for x belongs to open 0 comma pi by 2, normal to the curve at x is equal to pi by 6 also passing through the point. So, to do this problem, first we have to find equation of normal to the given curve at the given point. For that purpose, simplify the given function, otherwise calculation of derivative is very lengthy. So, 1 plus sin x by 1 minus sin x, write this as sin x can be written as cos 90 plus x 1 minus cos 90 plus x by 1 plus cos 90 plus x. We know 1 minus cos theta by 1 plus cos theta is tan theta by 2, hence tan inverse root over, this is 2 sin square theta by 2, 2 cos square theta by 2, this is tan square theta by 2, pi by 4 plus x by 2, that is equal to tan inverse of tan of pi by 4 plus x by 2, that is equal to pi by 4 plus x by 2. This is our function f of x is equal to pi by 4 plus x by 2, and we want normal at x is equal to pi by 6, and let us find the point when x is equal to pi by 6. When x is equal to pi by 6, y equal to tan inverse of root over 1 plus sin 30 whole divided by 1 minus sin 30 tan inverse root 3 is 60. So, the point will be x coordinate pi by 6 and y coordinate pi by 3. At this point, for this equation, write the equation of normal. We know derivative equal to, for y equal to pi by 4 plus x by 2, derivative equal to 1 by 2 means slope of tangent equal to 1 by 2. Hence, slope of normal is minus 2, hence equation of normal is 2x minus y, slope of normal is minus 2. So, equation of normal 2x plus y equal to 2 into pi by 6 is pi by 3. This is equation of normal, and the question is the point where the normal passing through. So, after getting the equation of normal, just verify the options 0 0 not satisfied, 0 comma 2 pi by 3 is also not satisfied, pi by 6 comma 0, see 2 into pi by 6, pi by 3 plus 0, hence pi by 6 comma 0 will be the correct answer. Next question, n plus 1 into n plus 2 so on 3n is given. Since every term is in the form of n plus 1 n plus 1, write this as n plus 2n by n power 2n whole power n by n. So, take logarithm for the given problem or write e power log of limit n tends to infinity log of given problem. So, n plus 1, n plus 2 so on n plus 2n whole divided by n power 2n whole to the power of 1 by n. When 1 by n comes outside, this is in the form of logarithm log x power n equal to n log x. So, e power limit n tends to infinity 1 by n into sigma. See, denominator is in the form of n power 2n. Since the numerator contains 2n terms, adjust every n term to each term. So, n plus 1 by n, n plus 2 by n, so on n plus 2n by n. This total n power 2n is adjusted to all terms. So, 1 by n into sigma log of n plus r, where r running from 1 to 2n means the total problem contains product of 2n terms. So, write this as, write the given sum as in the sigma notation r running from 1 to 2n log of n plus 2r, where e power limit n tends to infinity. Since this is in the form of f of r by n, write this as e power integral 0 to n log of 1 plus, when you take n common, here it becomes, after taking n common, here it will be 1 plus r by n. So, the total integral will be integral 0 to 1 log of 1 plus x dx. Since the problem contains 2n terms, it becomes integral 0 to 2 log of 1 plus x dx. So, do find the integration for log of 1 plus x, it will be e power 1 plus x into log of 1 plus x minus 1 plus x between the limits 0 to 2, and the answer is e power 3 log 3 minus 3 minus lower limit, this total term is 0 minus 1, that is equal to e power log 27 minus 3 plus 1 minus 2, that is equal to e power log 27 by e square, and the answer is 27 by e square. Next question, a equal to 5a minus b 3 2 and a into adjoint a equal to a into a transpose. Now given matrix is this, and put this matrix in the given condition, a into a is 5a minus b 3 2 into adjoint a. We know when the matrix is a b c d, adjoint is d minus b minus c a. So adjoint a is d minus b minus c a, this is adjoint a, is equal to a into a transpose 5a minus b 3 2 into a transpose is 5a 3 minus b 2, this is a into a transpose. Simply by multiplying these two matrices in left side and right side, in left side 10a plus 3b, and next 5ab minus 5ab 0, and next 6 minus 6 0, and next 3b plus 10a plus 3b, this is left side matrix, and right side is 25a square plus b square, and here 15a minus 2b, and here 15a minus 2b, and last 9 plus 4 13. This is left side and right side. By comparing both sides, you will get this is equal to this, but simple condition is 15a minus 2b equal to 0 implies b equal to 15 by 2a, and again 10a plus 3b equal to 13 implies 10a equal to 13 minus 3b, b is 15 by 2a, 3b 45 by 2 into a, that is equal to 13 minus 45 by 2a. When you 45 by 2a comes left hand side, it becomes 20 plus 45a, 65a by 2 is equal to 13, and this cancels 5 times, implies a equal to 2 by 5, this is a value, and b equal to 15 by 2 into a is 2 by 5 gets cancelled 3 times, hence final answers a equal to 2 by 5 and b equal to 3. But the given question is 5a plus b, find this value 5a, a equal to 2 by 5, 5a equal to 2, b equal to 3, hence answer is 5. Next question, the system of linear equations, these three equations are given, has non-trivial solution, and the question is how many values of lambda are possible for the given data. We know when the system of linear equations has non-trivial solution, condition is det equal to 0, determinant of quotient matrix means 1 lambda minus 1 lambda minus 1 minus 1 1 1 minus lambda is equal to 0. So implies by expanding this 3 by 3 determinant, 1 into lambda plus 1 minus lambda into this gets cancelled, minus lambda square plus 1 minus 1 into gets cancelled, lambda plus 1 is equal to 0. So lambda plus 1 plus lambda cube minus lambda minus lambda minus 1 equal to 0. Lambda gets cancelled, 1 gets cancelled, remaining is lambda cube minus lambda equal to 0 implies lambda into lambda square minus 1 equal to 0, lambda equal to 0 plus or minus 1. These are the values of lambda, and again when you put lambda equal to 0 also, you can observe or you can check the given equations. When lambda equal to 0, you will get 3 equations. For lambda equal to 1 minus 1 also you will get 3 different equations. All these equations have non-trivial solution. So you can verify the given equations with the help of these lambda values. You are getting, when for all these values of lambda we are getting non-trivial solution. So all are the perfect possibilities for lambda, hence number of possible values of lambda are 3 possibilities. When lambda equal to 0, you can simply observe that first equation is x minus z equal to 0, and second equation is y plus z equal to 0, and third equation is x plus y equal to 0. These are the three equations. By subtracting second from third, you will get x minus z equal to 0, x minus z equal to 0. Again it has infinite solutions, so lambda equal to 0 is perfect one. Similarly, lambda equal to 1, lambda equal to minus 1 also perfect values of lambda, where the given equations has non-trivial solution, means infinitely many solutions. Next question, question number 62. Find the value of theta for which 2 plus 3i sin theta by 1 minus 2i sin theta is purely imaginary. Since this is purely imaginary, simple information is real part of this complex number is 0. So let us write 2 plus 3i sin theta whole divided by 1 minus 2i sin theta, and rationalize this into 1 plus 2i sin theta whole divided by 1 plus 2i sin theta. Then numerator will be, we do not want total answer, since this is purely imaginary, we want only real part 0. So real part is equal to 2 into 1, 2, 3i sin theta, 2i sin theta minus 6 sin square theta whole divided by denominator 1 square minus 2i whole square, 1 plus 4 sin square theta. This is real part is equal to 0, implies sin square theta equal to 1 by 3, implies sin theta equal to plus or minus 1 by root 3. So given option is sin theta equal to 1 by root 3 or minus 1 by root 3, but in our paper only 1 by root 3 is given, hence the correct answer is sin theta equal to 1 by root 3 or theta equal to sin inverse of 1 by root 3. Next question, number of terms in the expansion of 1 minus 2 by x plus 4 by x square whole power n is 28, then find the sum of coefficients of all terms in the expansion. One way this problem is wrong according to given information, because to find the number of terms in the expansion, here only one variable is given. This is trinomial expansion. To find the number of distinct terms in the trinomial expansion, our expansion must be like this: ax plus by plus cz whole power n. Then we have formula, and we can calculate number of distinct terms in the expansion, but here the wrong thing is, in the given question only one variable is given. When you expand this expansion, in somewhere in middle steps, the x terms and x square terms or x square terms may get cancelled. So you won't get different terms in this expansion according to our known formula. That is the wrong in this question. So one way, this must be added question. If we are not satisfied with the explanation, or if the question is given as a correct question, other explanation is, if we treat this expansion as ax plus by plus cz whole to the power of n, for this type of expansion, number of terms are distinct terms are, our formula is n plus r minus 1 c r minus 1. For this type of expansion, to find number of distinct terms, always we use this formula, where n stands for power and r stands for number of distinct variables in the base. Here in the given question, all same variables are given. That is one mistake in this question. So in that way, this question must be avoided one. If it is not as not given as avoided question, then the suitable option is, for doing suitable option, we are following this. To follow this question, first of all our expansion must be like this. In that way only we can find number of distinct terms. For this expansion, without using this formula, we cannot find number of distinct terms, or in ordinary simplification we can find, but since the power is not known, we cannot calculate that. So by treating the given expansion as trinomial expansion just like this, number of distinct terms are, here 3 terms are given. So n plus 2 c2, that is equal to n plus 2 into n plus 1 whole divided by 2. These are number of distinct terms of the expansion, but given that number of distinct terms are 28, so n plus 2 into n plus 1 is equal to 56, implies n is equal to 6, or we will get quadratic, and one way one value is positive, one value is negative. Since we will not consider negative value, n equal to 6 is the correct answer. By taking n equal to 6, now the question is sum of the coefficients of all terms. To find sum of coefficients of all terms, sum of coefficients is equal to, in any expansion for this type of expansion, to find sum of all binomial coefficients, simply put x is equal to 1. By giving x is equal to 1 in the given expansion, 1 minus 2 plus 4 whole power 6, that is equal to 3 power 6, which is equal to 729. So, this is the suitable answer for our question. So, for this question there are two possibilities. One is it should be avoided question, otherwise the suitable answer is, appropriate answer is 729 by taking the given expansion like this. In that way only we can calculate the answer for the given question. Actually 729 is not the perfect one. For this type of expansion this is not correct answer. If it is not good given as avoided question, this will be the obvious suitable answer. Next question, sum of first 10 terms of the series. See, the each and every term of the series is mixed fraction. So, let us convert into perfect fraction. 5 plus 3, 8 by 5 whole square plus 10 plus 2, 12 by 5 whole square plus 15 plus 1, 16 by 5 whole square plus so on. Like that 10 terms of the series are given, we have to find the sum of all these series. For every term you can take 1 by 5 square common, 1 by 5 into, and from each term we can take 4 common. So, take 4 square also common, remaining 2 square, 3 square, 4 square, so on. Since 10 terms of the series we want sum of the 10 terms, so last term is 11 square. This is in the form of sum of squares of first and natural numbers, but 1 square is missed. So, add 1 square and subtract 1 square. This 1 square is 1, that is equal to 16 by 25 multiplied by 1 square, 2 square, 3 square, so on 11 square, n into n plus 1 into 2n plus 1 by 6 minus 1. This cancel 2 times, that is equal to 6 by 25 multiplied by, this is 23 22s, this is 46 46, 10, 506 minus 1, 505. Also 5 cancels 5 times and 101 times, and this is the final answer, 16 by 5 into 101. But the given information is sum of 10 terms of the series is, this is equal to 16 m by 5. So, 16 by 5, 16 by 5 also gets cancelled, answer is 101. The question is sum of first 10 terms of the series is given, and that answer is also given 16 m by 5. By cancelling both the both sides 16 by 5, we got m equal to 101. Next question, find the integral value of integral 2 into x power 12 plus 5 into x power 9 whole divided by x power 5 plus x cube plus 1 whole cube. This problem simply depends on adjustment. After some adjustment, we got the form of f of x whole power into f dash x. For that purpose, we have to take some quantity common either from numerator or denominator. Here, since denominator contains whole cube, by taking x common, outside it will be x cube. By dividing with x cube, the remaining terms will not be adjusted. So, the only correct way, take x power 5 from the denominator. After taking x power 5 from denominator, 2 into x power 12 plus 5 into x power 9 whole divided by, when x power 5 comes outside, it becomes x power 15 into 1 plus 1 by x square plus 1 by x cube whole cube. and again divide this x power 15 with numerator, that will be 2 by x cube plus 5 by x power 6 whole divided by 1 plus 1 by x square plus 1 by x power 5 whole cube. Now see this remaining quantity, 1 derivative 0, 1 by x square derivative is minus 2 by x cube and 1 by x power 5 derivative minus 5 by x power 6. So simply denominator derivative, or when you bring the denominator to the numerator, f of x whole power into f dash x. For that purpose simply multiply with minus and put minus sign outside. So integral 1 plus 1 by x square plus 1 by x power 5 whole power minus 3 into minus 2 by x cube minus 5 by x power 6, that is all. This is in the form of f of x whole power into f dash x. Since known formula f of x whole power n plus 1 by n plus 1, or by taking this is equal to t, you will get this as derivative. So straight away f of x whole power n plus 1, 1 plus 1 by x square plus 1 by x power 5 whole power minus 2 by minus 2, that is equal to 1 by 10 into 1 by 1 plus 1 by x square 1 by x power 5 whole square, and again by taking LCM the denominator becomes x power 5 1 by x power 5 plus x cube plus 1 whole square, and when x power 5 comes to numerator it becomes x power 10, hence answer is 1 by 2 into x power 10 whole divided by x power 5 plus x cube plus 1 whole square. So x power 10 whole divided by this whole square. So this is the integration of the given problem, just only by adjustment we got the answer. Next problem, sum of all real values of x satisfying the equation this is equal to 1. Here case 1, base is equal to 1 because 1 power finite equal to 1 implies x square minus 5x plus 4 equal to 0, x is equal to 1 or 4, these are two values. Case 2, previously base is equal to 1, now this time power equal to 0 is another case, x square plus 4x minus 60 equal to 0 implies factors product 60 sum 4, x plus 10 into x minus 6 is equal to 0 implies x is equal to minus 10 and 6. Since we take power equal to 0, base should not be 0. When you put x is equal to 6 or minus 10, you can observe that when x is equal to 6, 36 minus 30 plus 5 is not equal to 0. When x is equal to minus 10 also, base not equal to 0. So here two values x is equal to 1 comma 4, here two values x is equal to minus 10 comma 6, and other possibility case 3, that is base is minus 1, x square minus 5x plus 5 is equal to minus 1, because minus 1 whole power even is equal to 1. So let us start with base is equal to minus 1, the values we are getting for those values of x power must be even, only consider those values where the power is even and neglect the remaining values. Now by taking this x square minus 5x plus 6 equal to 0 implies x is equal to 2 or 3, and once again see when x is equal to 2, base is minus 1, when you put x is equal to 2 here, 4 plus 8 12, 12 minus 60 is totally even. So x is equal to 2, okay, but when x is equal to 3, 3 square 9 plus 12 21 minus 60 is odd, minus 1 whole power odd is minus 1, so do not consider x is equal to 3. Finally values of x are only these values, and sum of all these values of x is equal to 1 plus 4 plus minus 6 plus 6 plus 2, this is the required answer, hence total answer 1 plus 4 5, 5 plus 6 11, 11 plus 2 13 minus 10, 3 is the correct answer. So sum of values of x is equal to 3. Next question is, find the rank of the word small. This is the given word. According to dictionary order, find the rank of the word small. So, to do this problem, let us write the given letters in alphabetical order. That means, according to dictionary order, write the given letters according to dictionary order, and that order is A, L, L, M, S. Here first letter is S, and there are so many letters before A, before S. Number of arrangements starts with A. Totally this is 5 letter arrangement. Any arrangement starts with A comes before S. So, these arrangements are arrangement starts with A. When A is fixed here, remaining we have 4 letters can be arranged in 4 places, out of which 2 are repetitions. So, number of arrangements 4 factorial by 2 factorial. Next, in similar way, number of arrangements starts with L also, and for this answer is one L is fixed, remaining we have 4 letters, and 4 letters can be arranged in 4 places in 4 factorial ways. And again, since one L is completed, no need to write it second L, and there is no one more letter starts with M. Any arrangement starts with M comes before small, and here answer is M is fixed here and we have 2 L's. So, answer 4 factorial by 2 factorial. So, first letter comparison, that two arrangements beginning with the letter which comes before S or starts with A, starts with L, starts with M, these are the arrangements. And next, after first place is completed, now come to second place. In second place we have M, and before M A is there. So, any arrangement starts with SA comes before small, and number of such arrangements are 2 letters already fixed here, remaining we have 3 letters. In these 3 letters 2 are like letters. So, 3 factorial by 2 factorial, and again arrangement starts with SL. Here also 5 letter arrangement, 2 letters are fixed here, remaining 3 letters can be arranged in 3 places in 3 factorial. Here 2 like letters are there, that is why here this is 2 factorial, and here one letter is already fixed. We have 3 places and 3 letters must be arranged in 3 places in 3 factorial ways. So, S, L completed. We want the letters which comes before M. Before M, A is completed, L is completed. So, second place comparison completed. Now, third place comparison. In third place A is there is no letter which starts with A. So, no arrangement starts with SA or SMA, and for last letter is L, and in alphabetical order before L only one letter is there. So, any arrangement starts with L means fourth place comparison. In fourth place L is there, before L only A is there, already A fixed here. So, no arrangements in fourth place, and finally given letter itself is counted one time. So, these are the arrangements. These two are first place comparisons and these two are second place comparison, and this is the final one, and the answer is 4 factorial by 2 factorial, 4 into 3 12, 24, 12, this is 3, 6, 1, altogether 12 plus 24 36, 36 plus 12 48, 48 plus 3 51, 6 57 plus 1 58, hence total rank of the word small is 58. Okay. We are discussing the paper, today's mains paper. We are discussing the main paper with code E, contains the code E. So, question number 61, if f of x plus 2 into f of 1 by x is equal to 3x, where x not equal to 0, and s is equal to set of all x belongs to R, such that f of x is equal to f of minus x. This is given data. Then the question is asking about how many elements this set contains. This is our question, and the given options are S contains an empty set, contains 1 element, 2 elements, 3 elements, like that the question is given. So, first of all, based on the given information, f of x plus 2 f of 1 by x is equal to 3x, find the function, that is f of x plus 2 into f of 1 by x is equal to 3x. Here replace x by 1 by x, so that 2 into f of 1 by x plus 2 into f of x is equal to 3 by x. Take this as equation 1 and equation 2. From these two equations get f of x simply by cancelling 2 f of 1 by x, that is multiply the second equation with 2 and then subtract. So, if you multiply the second equation with 2, this gives 2 into f of 1 by x plus 4 f of x is equal to 6 by x. Then from this equation let us take this as equation 2. Now 2 minus 1 gives 2 times f of 1 by x, 2 times f of 1 by x gets cancelled, 4 f of x minus f of x, 3 f of x is equal to 6 by x minus 3x, implies f of x is equal to 2 by x minus x. This is the function. So, related to given question, this is f of x. Now, one more condition given is f of x is equal to f of minus x. So, given f of x is equal to f of minus x implies 2 by x minus x is equal to f of minus 1 by x minus 2 by x plus x, implies 4 by x is equal to 2x, implies 2 by x is equal to x, implies x square equal to 2, x is equal to plus or minus root 2. So, option is we got two values for x. So, the set S contains exactly two elements.